Welcome back, guys. So, today we'll be taking a closer look to the API server. As in this playlist in the previous video, I have shown you like the different components of the master node and the worker node. The API server is a part of the master node, as we have discussed earlier, and this is the central component used by all the components and by the clients such as kubectl. And API server provides the CRUD interface for querying and modifying the cluster state over the RESTful APIs. Okay, and it stores those state in etcd. It also handles the optimistic logging so that change in any object are never overridden by other clients in the event of the concurrent update. Okay, let us now dig a little bit deeper into the API server. Let us assume we have a pod YAML in place which has a pod manifest. We have kubectl the client, and we have the kubeconfig as well in place, like which has the details about the cluster. So once we do a kubectl create -f pod YAML, the request goes to the API server. In front of the API server, the first guy is the HTTP handler, wherein we have made the HTTP post request that reaches here. So with this request, what next needs to be done is authentication and authorization as like it happens on like any request. Same way here also we have the authentication plugin first of all in place, wherein using the client certificate or the HTTP header like authorization, API server validates the user as what it says it to be. Okay, so once this authentication is done, the next part comes is the authorization. The authorization basically means like if that user has the permission to do the specific tasks or not. Authorization is the place where the other rules are evaluated as well. So once these two things are done, and then we have the request, can we go ahead and proceed to create the pod? No, we cannot. So we have some admission controllers as well, wherein we have first the mutating admission controller. So this is in charge of looking at the YAML and modifying it. So like some things, the default things needs to be present in the YAML, like image build policy or DNS policy and other things. If they are not present, so this mutating admission controller will add these things in the YAML and then forwards the request. We have the schema validator plugin next. What schema validator does is it makes a quick check to ensure that the resource is valid against the internal schema. As in like things like mutation admission controller has added some lines into the YAML file. So it validates like if the YAML is correct or not. So once this is done, there's another admission controller in place that is the validation admission controller, and this is the last part. So this validation admission controller, what it does is it checks the resource against policies. Let's say we have a namespace, whether this resource can be created in a namespace or not. Okay, so this is what a validation admission controller does. And once all these steps are done, so herein the API server further sends the requests. Okay, so this is how like when we do make a create request for any resource. So one thing to notice here is like when we make a read request for to the API server, the request doesn't go through the admission controllers, so the request won't be going to these components. Okay, all right, so one of the API server tasks was to handle the request and takes it forward. This is what happens inside the API server when we try to create a resource. So how API server notifies the controller about the resource change? Okay, so we have various controller clients. These clients are the controllers. So what happens is controllers watch for the changes by opening an HTTP connection to the API server, as like putting a get request to the API server with the watch equals to true, So this we have seen in kubectl as well. Like if you might have used this -n watch option in kubectl, so you get a event updates like every 2 seconds or so. Similar way, this uh, controller gets the update. Okay, so through this connection, the client will then receive the stream of modification to the watched object. Okay, now let us say we have requested to create a pod xyz via kubectl. Okay, so that object gets updated in each cd first, and then there's a notification that each cd has updated. It has an object in place, and as we have seen, like this client, the controller has a continuous watch on the API server, send the updated object to all the watchers, right? And further, the request will go on and on, and the resource will be created. So this is how the API server notifies the controller about the resource change. Okay, so these are the things that API server does. Okay, I hope you understood these things. If there's any doubt, clarification needed, please don't hesitate to comment. And yeah, please do subscribe if you like my videos. Thank you for watching. Have a good day.